In this lesson, we will summarize some additional patterns that may also be beneficial in your design. The following patterns are less often applied in designs than the one we have covered so far. However, it is beneficial to be aware of them so that you can recognize them when you may need to use them. The approximation pattern is used to reduce the number of resources needed to perform some write operations. This pattern uses an approximation function to produce a result. For example, if an application wants to track page views, it could write to the database every time a page is viewed, but this could quickly overload your database with hundreds of thousands of extra writes per day. In this case, instead, an approximation function can be used to increment the counter only once in a while, instead of doing a write for each individual page view hit on the server. The approximation pattern is used whenever there is a significant tolerance to data imprecision, or when an operation is expensive to compute with very little value added by precision. Its implementation is to do fewer writes, but with a higher payload. The application can do the operation every 10 operations, 100 operations, or whatever factor makes sense. Typical use cases for the approximation pattern are web page counters, any counters with tolerance to imprecision, metric, statistics. The typical benefits of this pattern are a reduction in the number of writes, less write contention while updating the same documents, statistically valid numbers, even if not exact per unit of time. The implementation of this pattern must reside in the client-side application. This pattern is not specific to MongoDB. It can be used with any other databases. However, the need for this sort of optimization surfaces more often with big data applications. Our next pattern is used to handle potential outliers in your data. An outlier is something that stands out from the rest of the crowd. In the world of big data, standing out means you may have a characteristic that is few orders of magnitude higher than the norm. For example, a famous singer may have 100 million followers on a social media app, while the majority of users have less than 1,000 followers. The danger with outliers is that they could drive developers to implement a solution that is suboptimal for 99.99% of use cases, just to accommodate the outlier. Implementing a solution like this will unnecessarily harm the majority of queries. Do not be afraid of implementing a design that works well for the vast majority of use cases, and then identifies these outliers as exceptions. The application can then be instructed to handle just these outliers differently. Here's an example of implementation where a document representing a movie has a field to store a list of extras up to 1,000. This will work for almost every movie. If a movie happens to have more than 1,000 extras, it refers to additional documents that contain the rest of the extras. Typical use cases for the outlier pattern are social networks and other applications related to popularity, apps containing famous people or objects. The main benefit of this pattern is that the application remains optimized for most use cases. The drawback is that the application must handle the outliers separately, and it makes it harder to write queries that can process the whole dataset in one uniform operation. As with other patterns, this one also is handled on the client side, meaning that it can be used with any database. However, it also surfaces more often in modern and big data applications. To recap this lesson, we listed some additional patterns that may be seen less frequently, but they are still worth knowing. The first is the approximation pattern, which allows us to reduce the number of resources used by an operation that may not be crucial and can be approximated. The outlier pattern allows your app to optimize for the most frequent use cases while still successfully handling important outliers.